multiple things. Okay, so we're running the test rig. You want to use the camera?
Yeah. Well, what I can do is it recording?
Yes, it's recording.
Okay. Well, I'm going to start it over again, and we're going to do the factory speeds. We'll set it to low.
So, on the solid state?
No, we're going to actually do capacitor. I'm going to put this on his camera for him to upload. So we're going to turn it on high. It's on low here, and it's on high here. And we're drawing 1.08. And then, of course, medium.
Yeah, I noticed the maestro tag isn't running.
And then 1.56 is what we're drawing. Oh yeah, medium.
It's a medium.
Yep. And then here comes high. And then, and that's drawing 2.61 is what it's drawing on high. And then we're going to do spin down.
Spin down, of course.
Yep.
Spin down.
Yep. Okay. It's still going. It's a long spin down for a box fan. Okay, since it's set to high, we're going to do the decade box again. I'm just going to go through it for the video. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nothing on 10, so I'm going to hit 10.
10 switch.
Yep, 10 switch did not start.
It doesn't start.
11, 12, 13, 14, 15, 16. I went, oh, 16 is where it starts.
It's even drawing.
It's
before
draw.
the speed that it turns on.
Oh yeah, it does draw current, but it's not enough to start it. It's not enough. And 0.92, and on antique ceiling fans like a Westinghouse Sidewinder, like downstairs, we've tested those. Those do not start till about now, till like where I have it at 16. It takes, so a wall control for those will not work. Like a 3 or 4 speed, because it's not enough capacitance to start it even on low.
Like a normal speed dial.
Yeah, you need like a solid state for them, which I will show you. I'm going to continue. 0.99 on 17. 1.07 on 18. 1.15 on 19. 20. 1.23. 21. 1.32, 22, 1.41, 1.49 on 23, 1.58, 24, 25, 1.67, 26, 1.76, 18, 1.85, 19, 1.95, 19, 2.04, 20, 2.15. Now I'm going to turn off the, I'm going to add 10, so I have 31, so I have 30.
I was just like, because I was kind of questioning.
Yeah, sometimes I forget. I usually start a lot lower and get draw, so 32 is 2.25. 33, 2.37, 34, 2.47, 35, 2.59. Now watch this.
Connor, watch. It'll be fine.
It's fine.
It's fine, Connor.
36 is 2.7, which we're over. Now watch this. I flip on high, and it drops to 2.6. That means we're over, so we know as high as we can go. Well, not only that, it's too much capacitance. That's more than the motor can handle, is what it is. But if it's very brief, like a quick second where I say we're high, we just turn it back, no damage is going to be done. But you don't want to leave it over. Like, are you familiar with 4 speeds on a wall control? Okay, sometimes some vintage fans, Dan's discovered the high medium, that's the speed below high, actually sends the current over high, and then you don't want to use that control. It's too high of a capacitance, like an 81220. So now what we're going to do is the solid state, which is like what an industrial typically has.
So it spin down so we can see if it starts up on.
Oh yeah, I can't stop it by hand since it's enclosed. Usually ceiling fans at this point we'd stop by hand. Okay, I'm going to start on the solid state and see where it starts. And we get a current reading.
It's not.
Nope, I'm turning it real slow.
Went up to about 0.5.
I hear it buzzing.
Oh, it's starting.
0.6.
There it is. There it goes.
Yeah, 0.64. And it's about at 2 o'clock on the dial, which is this.
Less of a current than started on the capacitors, right?
Yeah, but solid state is starting lower.
I can't believe it. They do it.
Okay, I'm going to go 1/8 of a turn and do 0.84. Another 1/8 of a turn, 1.09.
1 o'clock.
Yep, I'm going to go right to noon with the solid state. I call noon because it's straight up. 1.4. I'm going to go to 11. Go to 11. 11. 1.83. 10 o'clock. 2.1. 2.10. And then I think I'm pretty much at high. Right there, that's high. And I'm drawing a little under the actual current of the factory speed, which is 2.62 or 2.61. Solid states always draw a little bit under because it's not the cleanest AC. It's kind of like a dimmer switch, but this has a filter to filter some of that DC current that dimmer switches give off. So this one's kind of got dirty AC to it, and it draws a little bit under the actual current on a solid state. So that's always going to be the case. Now the last test we do, we got to let this one spin down again, was called 0 to high. What we watch for is...
Just start it up on high. Just start it up on high.
Yeah, we're going to start it right up on high. We want to see if the current spikes above what you get when it's running, when it initially spikes.
Oh, okay.
Like
a
it-
turn on. When it kicks
Yeah,
on.
it kicks...
Does that for like a second?
Yeah. Yeah, it's called an inrush current. Inrush current draw, and then it drops back down to a steady reading. Okay, here we go. 0 to high. I'm going to put the camera on the meter and watch how high up it spikes.
Whoa.
Okay, 3.08 was...
3.13.
Oh, yeah. That was a quick second. Yeah, I was...
Real quick.
Look. If they just went down. That's so big.
3.13.
My goodness.
Spike.
Yeah, now I'm drawing 2.59.
Yeah, which is about what it's been.
Yeah. Yeah.
It seems to be dropping as we run it. I wonder if maybe the bearings are a little stiff.
It could be sometimes resistance causes it to draw more current. So...
Alright.
So that's all for this, what is this one? The
EXL.
EXL, all for the EXL. All right, and on to the next fan. I'm going to stop it.
I like this one.
Yep.